All right, welcome to Unit 3. Unit 3 is going to be all about atoms. We're going to talk about what makes up atoms, their structures. We're going to talk about their nucleus specifically. At the end, we'll talk about nuclear chemistry and stuff like that. But today, we're going to focus just on the beginning, and that's just atomic structures and then variations of atoms. Okay. So what are the subatomic particles that make up an atom? Now, you should have learned this in biology a couple years ago and probably in middle school science classes, but everybody knows the three subatomic particles. There's protons, which have a positive charge and they're found in the nucleus. They usually have a large mass compared to the other subatomic particles. There's neutrons, which are neutral, which have just about the same size mass as protons, also found in the nucleus. And then outside, floating around in the electron shells or orbitals are known as electrons. These have a negative charge and they're much, much smaller than the two guys in the nucleus. In a neutral atom, the number of protons should equal the number of electrons, and that should make sense because that's why we consider it neutral. It does not have a charge because there's no extra positives or extra negatives. Okay. Now let's talk about some of the numbers that represent these different subatomic particles. I'm sure, again, this should probably just be a review, but the atomic number is the number of protons. The number of protons in an atom can never change, okay? Because if I change the number of protons, that means I'm actually changing the atom. For example, nitrogen has an atomic number of 7, which means it has 7 protons. But if I added a proton to nitrogen, now it would have 8 protons. It's no longer nitrogen. Now it has become oxygen. So the number of protons cannot change if the element stays the same. But the other two guys, neutrons and electrons, can change, okay? And that's why we need some of these other numbers that we're going to talk about today. The mass number, for example, that's the total number of particles in the nucleus, okay? It's the number of protons plus neutrons because these are the only two particles found inside the nucleus. And then there's something else you need to know. It's known as the isotopic symbol or isotopic symbol, however you want to pronounce it. This is a chemical symbol, the same one that we've learned. It's the letters, whether it be 1 or 2. Okay, but we also put the mass number and the atomic number. So here you can see for fluorine, I have my chemical symbol F, but then to the left of it, I'm going to add my mass number on the top and my atomic number on the bottom. Okay, this is known as an isotopic symbol. So what are the variations of elements? Well, there's two major groups, variations of atoms. Okay, the first one we just talked about a little bit. Those are known as isotopes. Isotopes differ in their mass number because they have different numbers of neutrons. Remember, I cannot change the number of protons, but if I change the number of neutrons, okay, it's still the same type of atom, but now it's just an isotope of that atom. Okay, isotopes again are chemically alike because they have the same number of protons. So for example, here's 3 different examples of isotopes of carbon. There's carbon-12, carbon-13, and carbon-14. We give them their names based on their mass number. Now, one of these 3 is going to be known as the common isotope because it's the most abundant in nature. Usually, the common isotope is going to be, if I look at that red number on the top of my periodic table, it's usually going to be the number closest to that number. So if I take that number and if I round it to the nearest whole number, that's usually going to be my common isotope. Now, we'll talk more about why that is later when we talk about atomic mass. But for right now, all you need to know is that there's a common isotope, and that's the one, again, that's closest to that number on the periodic table. Okay. The other variation of an atom is known as an ion. Okay. If an atom has gained or lost an electrons, that gives them an electrical charge. So, for example, I have sodium here, Na, and I have chlorine, Cl. Now, obviously, it looks like Na has 1 extra valence electron, or in other words, electron on its outer shell, and chlorine has 7 with 1 opening here. Well, obviously, you can read the writing on the wall. Sodium's going to lose his electron and give it up to chlorine, who's going to take that electron. Now, since Na has now lost an electron, remember that electrons have a negative charge, so now the whole atom is positively charged because it has 1 extra positive charge compared to its negative charge. So inside, Na would have 11 pluses, but on the outside it would only have 10 minuses, giving it an overall charge of +1. Cl would be the opposite. Cl started with 17 protons and 17 electrons, but now since I've added an electron, therefore it has a negative charge. Okay, so that positive to negative causes something known as ionic bonding. Okay, that positive to negative. Now, there's different types of ions. There's cations and anions, okay? If an atom has a positive charge, that's known as a cation. So in our example, we have Na, it's a cation, okay? Anions then are the ones that have a negative charge. A negative charge. That's how I always remembered it. A negative ion. A negative ion. Anion. Okay. Now, if these two examples, we lost one electron, gained one electron, so it's just a plus and a minus. But if you were to lose multiples, like for example, magnesium and oxygen here, magnesium is going to give up 2 of its electrons to oxygen, and oxygen is going to gain those 2. Well, now I just can't write Mg plus. What I would actually write is Mg2 plus or O2 minus. So what are the subatomic particles that make up an atom? There's protons, neutrons, and electrons. And what are the variations of atoms? Remember that there's isotopes and there's ions, and then inside the ions there's either cations or anions. Cations are always positive, anions are always negative. Now, let's make it happen. You have a worksheet that's got a big table on it with a bunch of isotopic symbols, numbers, and things like that. What you need to do is determine the missing numbers using the information provided. Just remember that if I take the mass number minus the atomic number, that's going to give me the number of neutrons, because the mass number was protons plus neutrons. Atomic number is just protons, so if I subtract those two, I should get the number of neutrons. And then I need to classify each of the elements. Is it an isotope? Is it a common isotope? Is it a cation? Is it an anion? Or is it neutral? Okay, I can tell if it's an isotope or a common isotope based on looking at that number on the periodic table. Okay, if it doesn't match, when I round it to the nearest whole number, okay, if it does match, then it's the common. If it doesn't match, then it's just an isotope. Okay, good luck. If you have questions, refer to the key that's on the website, or you can contact me at jkubuske@gocathedral.com. Have a great day and good luck.